Hello, beautiful people. Future me. Let's get into it. Ah, 89. That's not too much. Well, I don't have much to say. I'm slower. Ah, come on. Alright, 4 minutes almost. So, 5%. That's not bad. That's not bad. Just keeping the practice, steady as we go. Alright, so we'll attack execute program today as well. Pick randomly from the free topics I can study there right now. It's JavaScript all the Typescript. Okay, that is a change. I was doing Typescript lately all the time. Continue. Yes, what? Okay, login accounts. String number. Okay, so it will say on there 557, right? Yeah. Write the index signature for an object that maps a person's name, a string, to a city. Like so, right? String or undefined. I, I need to pay more attention. Type usernames. Well, string. Yeah, it will. If we get Betty, we'll get undefined, right? Type, login accounts, string number. Okay, here is the error because the signature should be the same. Here is a number and here is a string. So this is error. Type error. That was the type error, right? Yeah. Ah, crap. That's what happens. Okay, and here I had the problem with it takes a string, the name, string, and then here is a string or undefined, like this. That is correct. And here what did I did wrong in here? Yeah, the type error. Here's the number, here's the string. Yeah, okay, very well. Well, let's do the thing. Console, and we will do mat seal mat random times how many? 3. It's 3. TypeScript has a special type called any. It means that what it sounds like a variable with this type can hold any value at all. Value with any type can be assigned to any variable regardless of the variable's type. hmm You might ask yourself why we haven't told you this earlier. It makes everything so easy. Yes, but it also prevents the type system from ensuring that variables have the types that we think they have. All bets are off when you use any. For example, we can put a number in any, then assign it to a variable of type string. Yeah. The thing that is wrong, but it won't cause a type error. Oh, so that's that's bad. With anything can be assigned to anything. We can do things that are complete nonsense, like assign user object to variable that's supposed to be an array of numbers. This example doesn't cause an error. The user will be in numbers variable. You can think of any as temporarily dropping you back into a regular JavaScript, where everything is dynamically typed. For that reason, you should try very hard to avoid any, not because dynamic typing is quote unquote bad, but because the whole point of learning and using TypeScript is to get static guarantees. However, there are cases where we want to use any. TypeScript was designed to interoperate with the entire ecosystem of existing JavaScript code. It's quite good at encoding static types for JavaScript code, but it's not perfect. And there are extreme cases where TypeScript could theoretically express the JavaScript code's types, but JavaScript code's types is not worth the effort. Code types, JavaScript code types. What is it? If you do find yourself using any, you can use conditional narrowing to bring the value back into the world of static types. For example, suppose that we use a JavaScript library to query a number from a database. Conditional narrowing to bring value back into the world of static. Okay, JavaScript library to query a number from a database. The library's TypeScript type definitions aren't very good. Mhm. So the number comes back with the type any. We can use a tape card to narrow the type back to number, throwing an error if it's any other type. From that point forward, we can rely on the type system again. It won't let us assign the number to a string variable, for example. Good number. Yeah, this is the safe number and returns number. If type n of type of n equals number, then we will return it. Otherwise, we will throw new error. Got a non-number. And I will have a I'll hold it. I'll do the whole 30 minutes. Const any 5 number safe. Okay, so this one should get us the error. Got a non-number 5, yeah? Get number from database. Oh, that's okay. Use any to make the code below compile, even though it's wrong. When building systems with TypeScript, remember to use any only as a last resort because you don't want this kind of bug in your code. Hmm. I did this already, didn't I? Nullish coalescing. You already seen this lesson before, but you had a trouble with some of these reviews. Here's a refresher. Okay. In a previous lesson, we saw that Boolean operators can be dangerous because 0 and empty string are both falsy. Watch the number or 1 case here. That's where the bug lives. Remember that 0 acts like false when used in Boolean operators. So this one will get us, oh yeah, so this is 3, 1, 1, 1, 1. And I have to look at this one, so this will return first truthy value. We'd expect number 1 to return 0, not 1. When we first introduced this problem, we recommend using a linter. A linter will catch this bug, which is good, but it also makes us write word code. Here's a correct version of the number or one function that works correctly and compiles with tslint or eslint. So that's using the ternary operator. Okay, so this one will return 3, 1, 0. This seems like a small price to pay. Holy cow, there are trees falling down. seems like small price to pay. And that's only because it's small, isolated example. In real systems, this overheat can add up. One problem is that this operation is so common in React applications, for example. It's very common to use this method to substitute default values for missing props. The problem also gets worse when the undefined comes from a more complex expression. In the numbers towards function below, the undefined comes from a function call. We have to store the function's return value in a variable, then test it against undefined when using the ternary operator. So we have the numbers towards, and we put that one. Okay, so it takes an array of numbers. Then we will return numbers and we will map it. And we take n, which is the number. Then we define a constant word. We get number to word. And if it's undefined, we will have some number, otherwise we will get that word. Okay, so we have for 1, we will get 1. Second one is undefined, so that will be some number. I wonder if I can do this, like makes the quote. I can. And there's a better way to do all of this. In 2019, ECMAScript got a new feature called nullish coalescing, designed to make this kind of code shorter and safer. That feature was immediately implemented in Typescript 3.7. The nullish coalescing is the question. It's like pipe, so we can use it to provide default values when something is null or undefined. But unlike pipe, it doesn't have the problems with zero and empty strings being falsy. When you write A, question B will only get B if A is null or undefined. So only when it's null or undefined. And it's from 3.7. Maybe we can use this. Now we can rewrite our original number or one function to be both correct and terse. Terse means short, right? Dense. Okay. So now we will get this is 3. Then we will get 1. And here we get 0. And that gives us this one only when we have here null or undefined. Okay. The question operator isn't a Boolean operator like pipe. It's only used for checking null and undefined. Uh-huh. If we run false question A, we'll get back false. We get back false because false isn't null or undefined. That is awesome. That is awesome. It was in 2019 ECMAScript. That is awesome. So now this will return 1, this will return 1, this will return false. Use the nullish coalescing operator to write a function name or default that returns a person's name. Okay, can I do it like in here? Let's say null question one. It doesn't know it. Use the nullish coalescing operator to write a function name or default that returns a person's name or will fault if the name is undefined. String undefined, it takes name, undefined. Okay, so first of all it will return string, then we will return name uh, fort, right? Yeah, like so and so. Okay. Finally, a note on terminology. Why is this called nullish coalescing? The coalescence part is old. For example, in the 1992 SQL standard introduced a coalesce operator which takes many arguments and returns the first one that's not null. If you squint, this sort of matches the dictionary definition of coalescence. Coalesce. Come together to form one mass or wall. Many values go in, one value comes out. Many languages have a null coalescing operator similar to the one that we've seen here and similar to SQL coalesce. Then why is this one called nullish coalescing rather than null coalescing? Because JavaScript and therefore TypeScript have two kinds of null, null and undefined. And defined is kind of like a null, it's null-ish. Putting all together, we can read nullish coalescing and returning the first value that isn't null or undefined. Okay, good. Hmm. Okay, so I have optional chaining. What else? I will finish it in 4 days if I do 2 lessons per day. What about this guy? 6 days. And then the JavaScript. The JavaScript is the biggest one in here. I have 68%. He say 7 days. So in a week I should be done. Or I could be done. see. Let's see. Well, the time's up. Time is up. That means we are done. Done is better than perfect. We'll see you next time.